Hello viewers, welcome back to another section of our tutorials. In this video, I'm going to take you through short circuits and open circuits in applied electricity. You've heard of short circuits, you've heard of open circuits. What are they? That is what I'm going to take you through in this video. Kindly subscribe, watch this video to the end so you understand every part of the video. Now let's tackle short circuits first. When you say a short circuit, what does it mean? Short circuit. So the word is short, meaning the circuit is very short. When you have an electrical network and you realize that there is a path the current can take instead of passing through its normal route, then we say it has a short path or a short circuit. So theoretically, a short circuit is a zero resistance path. Zero resistance path or connection between two nodes. So whenever you have a short circuit, one node is here, one node is here, there is zero resistance, there is no resistance there, and it's theoretical because every material have internal resistance, so it's assumed that the wire itself will have an internal resistance. So this short circuit here is a theoretically zero resistance connection between two nodes, and this short circuit has a negative effect on our circuits and can damage circuit boards. So let's see how short circuits affect our circuits and also how to identify short circuits when you are handling electrical networks. So now let's see. I have this circuit here. I have my voltage source V, then going into this branch to this, to this, to this, to this. So here is A, B, C, D, E, F, G, H. So this is it. This R1, this is R2, this R3. Let's see this circuit and see if you find a short circuit. Current moves like water. It moves up, and on its path it wants free path, so it doesn't need obstacles. See resistors as obstacles that block its flow, and if you have water flowing through a pipe and it encounters an obstacle, it changes direction or it takes path which has no obstacle, or if there is no option it will then be forced to either stay or pass through. Likewise, current. When current is flowing through a connecting wire, it just wants the free path to move freely. When there is a resistor, it decides and it senses whether I can pass anywhere other than this obstacle. If not, I'll pass through the obstacle itself. So let's see, since the current is produced from this branch, when it reaches this node, it will ask myself, I can see some obstacle here. There is nothing here, so it will pass through this side and return back to the circuit. And this is what we call the short circuit. The current has skipped all these parts and it has rather entered the circuit back from this side. So this is what we call a short circuit. So now the connection BG is said to be a short circuit. That is the concept of a short circuit. So let's see an example here. I have my voltage source V going to one resistor, another resistor. So this is resistor R1, resistor R2, then this is my voltage source, my resistor R3 to go and come back. So when I have this connection here, can I identify any short circuit or which of these resistors have been short circuited? Current will flow through here. It will have no option except to pass through this. Upon reaching here, I will ask myself, I can see an obstacle here, I can sense an obstacle here, but there is a free path here. So upon making decision here, the current will just skip all this and realize that the circuit is basically this way, and it will return back to the V, and this R1. So the R2 and the R3 have been short circuited. That is the concept of short circuit. Now let's look at open circuit. When we say an open circuit, What is an open circuit? An open circuit is infinite resistance. Infinite resistance. Whenever there is an air gap between an electrical network, we say there is an infinite resistance and current cannot cross this level. So assuming you have a source here and this point, this is an open circuit. The resistance is infinite so that current cannot jump from here to this side. And whenever there is an open circuit, there is no flow of current and that whole section will be off. So let's see this circuit here. I have my R1, I have my R2, then I have my R3, I have my R4, then finally R5. So with this open circuit here, current will start and it will come here. Upon reaching here, there is an infinite gap here, so it can't come here at all. So it will just pass here and come back. And that is an open circuit illustration. Open circuit represents switches. When you open a switch, it creates an open circuit. Hence, there is no flow of current. That is the concept of short circuit. And let's see the application of short circuit in solving a problem. So determine the total resistance. Determine the total resistance in the circuit below. So I have 4 ohm. I have this here. So here is 2 ohm, here is 3 ohm, here is 7 volts, then this place is 4 ohm. So when I have this circuit, determine the total resistance below. You need to find the effective circuit, the part of the circuit which is working. That is, if there is any short circuit, you identify. So current will move from here. Just take it easy like you are following a path. It will have no option to pass through this 3 ohm resistor. Upon reaching here, current will make a decision. I can see that there is a part here, there is a part here. When I sense this part, there is a free part here. And when I sense here, there is an obstacle, there is an obstacle. So why don't I take the free part? And you realize that the current will just pass through here. And the total resistance is actually 3 ohm. And the 4 ohm and the 2 ohm has been short circuited. That is it. Thank you for watching me in this video. Please subscribe to support. Don't forget to like and share.